Welcome back to our notes in Unit 1, Scientific Foundations for AP Psychology. We're going to be talking about research methods in this set of notes, these being your learning targets. Really, there's just one big one, and that's research methods, knowing the difference between them and the benefits of each. So have your notes, which are linked below from my Teachers Pay Teachers store, and let's get started. The first big concept we need to talk about in research is correlations. And I want you to notice that there's two really root words here. There's co and there's relations. So correlations is when there's a relationship between two variables. And that relationship can go both ways, right? Now, stay tuned because we're going to talk about this more, but that does not mean that one causes the other. It just means that they are in a relationship and they have an influence on one another. So make sure you get that. If you need to rewind or pause and write that down, make sure you do. Two variables that have a relationship or influence on one another. Now, there's two directions that could go. They could rise together and fall together, right? Increase and decrease together, or one could increase and the other decreases, and vice versa. So we call a positive correlation one where the two variables increase together and they decrease together. It's a positive correlation. Now, I want you to hang on to this next tidbit I'm going to tell you because we talk about it in learning and later on in different units. Positive in psychology, 90% of the time, does not mean good. Positive does not mean good. It means adding something, or in this case, it means going up, and that there's a positive slope. So hang on to that for a second, and we're going to talk about what that means in just a minute. An example of a positive correlation where two variables increase and decrease together is the number of gallons of gas pumped. So as gas pumped rises, it's positively correlated to the amount spent on gas. So the more gas you pump, the more you spend on gas. But you could also say the less you spend on gas, the less gas you have pumped, right? So they rise together, they fall together. That makes it a positive correlation because they go in the same direction. Now, a negative correlation does not mean bad. Negative does not mean bad here. It means when two variables move in opposite directions of one another. And I very much encourage you, when you're looking at scenarios in class and tests and quizzes, whatever, that you use your fingers. Or when you're on the quiz question or the test question and you see, for instance, number of gallons of gas pumped positively correlated with the amount spent on gas. Okay, so I'm going to draw a little arrow above the gallons of gas that, okay, as that goes up, what happens to the other one? Oh, that one goes up too. So either use arrows on your paper or use fingers. It's just helpful. So with negative, two variables move in opposite directions. An example being miles traveled is negatively correlated to the amount of gas left in your tank. So the more miles you travel, the less gas you have in your car. So you could say the more gas you have in your car, the less miles you have traveled on that tank of gas, right? And vice versa. So that's what makes it negative. They go in opposite directions there. Now, scatter plots are a graph that's comprised of points generated by values of two variables. A scatter plot is a graphic representation of a correlation. I want you to write that down. If you need to pause and rewind, please do. A scatter plot is a graphic representation of a correlation. So it's just a correlation on a graph. That's all it is. So the slope of points depicts the direction. So the slope of the points, the line of best fit, shows you the direction, and the amount of scatter shows you the strength of the relationship. So you'll see in this graph that it has a perfect positive correlation. Now, we're going to talk about what this little number here means here in just a minute. But for now, you notice that this would be a perfect correlation because there is a very exact line of best fit. That really doesn't exist in the real world. A perfect correlation does not. Whereas this one would be a perfect negative correlation, and that the relationship is so strong. Now, this one has a really big scatter, right? You really can't find a line of best fit. It looks like it's probably negative, I think. But there's really no line of best fit, and so there really is no correlation there. So the big points that you need to take away from this is that the direction of the slope indicates positive or negative relationship of the correlation. And then the amount of scatter, how much scatter there is in the points or in the number plots on the scatter plot indicates the strength. So the more you can find that line of best fit, the stronger the relationship. Now let's talk about that correlation coefficient, which is that number that you saw back here next to each graph, the positive or negative 1 or even the 0, and it's anything in between. Anything in between a negative 1 and a 1 is going to fall where the correlation coefficient would be. So it's the statistical measure that shows the degree of relationship between two variables. It's just the number that shows you the correlation, whether its direction and its strength. So the R equals would be the correlation coefficient, okay? And in this instance, it's positive 0.37. I want you to cover up one thing at a time. There's two things in a correlation coefficient. There's the positive or negative sign, and then there's the number. Take them separately. And when you first start looking at correlation coefficients, I want you to cover up one or the other when you're looking at it. So what I recommend doing is covering up that number, right? Like just cover it up on your paper or on your screen. And only look at the sign, which in this case is positive. It indicates the direction of the correlation, meaning the slope, right? So the scatter plot slope, if it's positive, your correlation coefficient will have a positive sign. Then look at the number. The number alone, having nothing to do with the sign, indicates strength of the relationship. And really, the number only falls between 0 and 1. Because like I said, even though it's negative 1, the negative sign has nothing to do with the number. So let me say it one more time. The sign only indicates the direction, positive or negative, and the number only indicates strength. So a negative 1 and a positive 1 are equal in strength. The negative and the positive have nothing to do with strength. Got it? Okay, so the coefficient will always fall between negative and positive 1. The closer, whether it's positive or negative, to 1, the stronger the relationship. Okay, so the closer it is to negative or positive 1, the stronger it is. The closer to 0, the weaker it is. So let's look at some correlation coefficient examples, and I want you to jot these down in your notes. So what would a positive 0.78 be? What's the direction? What's the strength? Hopefully you notice it's moderately strong and it's positive, because moderately strong being 0.78, that's actually pretty strong, right? Like there's really no correlations out there, or not very many, that are even a 0.9 or above that. So what could be an example correlation, meaning two variables, with this correlation coefficient? And I want you to jot those down and discuss them in class. What about a positive 0.05? Hopefully you notice that that's really weak, because it's really close to 0, not 1, but it's still positive. And then again, come up with two variables that would have a relationship like this. So let me give you an example for this one. Let's say happiness and wearing purple socks. They probably don't have very much to do with that, right? Whereas an example back here for a positive 0.78, let's say it's as height increases, weight increases, right? They go in the same direction and they're pretty closely related. All right, let's look at the next one. Negative 0.43. How strong is it and what direction? Hopefully you see that it's a negative direction, but it's moderately weak, right? Like it's almost in the halfway point, but it's on the weaker side. Negative 0.92 is really strong, but it's still negative, right? Like it's negative, but it's still really strong. So come up with two variables that would have that correlation coefficient. All right, let's look at another example here, but on a scatter plot. So what we've got is temperament scores. And yes, that has something to do with your temper, but it's really your emotional reactivity to life. Are you kind of high strung, or are you really easygoing? And that temperament is really visible and noticeable even in infants. And then height in inches. So let me ask you this. How closely related is your height in inches and your temperament? Not really. Short and tall people can be angry all the time. Short and tall people can be really mellow, right? They really don't have a lot to do with each other. So, but look at this graph. Here's a chart showing relationship between height and temperament scores. What relationship is depicted? So I'm hoping that you can look and see that the line of best fit would be going upward, which makes it positive, and that you could probably guess that it's really not that strong, but it's not weak either. So it's going to be somewhere around the 0.5 or 0.6 range. All right, so let's talk about correlation and causation. So knowing two variables, height and weight, height and temperament, gas used in miles, something like that. Knowing that two variables are correlated or related does not necessarily tell you why or how they're related. And it certainly doesn't tell you the direction of the relationship, meaning which one causes the other. Here's an example for you. Low self-esteem causes depression, right? Yeah. But doesn't then depression also cause low self-esteem? Yes, it does. But then isn't there other things that could cause both low self-esteem and depression, like distressing events or biological predisposition? Yes. So there's no way to say, if you're only looking at two variables, that one causes the other, because it could be a third variable that causes that relationship itself that you're looking at, right? Biological predisposition could cause both low self-esteem and high depression. And so you can't say that one causes the other. Correlation does not mean causation. And on test questions, especially those from College Board, they're going to try to trick you. And if they say, like, look at this correlation, what is it? And they say, like, in one of them that low self-esteem causes depression. No, you can mark that out. It's asking for a correlation, and correlations don't determine cause. All right, so let's look at three types of research. We're kind of done a little bit talking about correlations. Now let's talk about descriptive or observational research, which is simply describing a behavior. The correlation again, and then experiments. And experiments being controlled settings, a controlled setting with manipulated variables. All right, the first one we're going to look at is naturalistic observation. It's just observation of human or animal behavior in its environment, in which the behavior typically occurs, right? Jane Goodall is an example of this, where she went and lived with the groups of gorillas in order to simply observe their behavior. And that when you are doing a naturalistic observation, you are not interfering or manipulating anything at all. You're simply observing. And that really can glean a lot of really good information. So it's valuable where other methods are likely to be disruptive or even misleading. But there are some problems with naturalistic observation. If people or animals know they're being observed, they tend to act differently. This is called the Hawthorne effect. I would make sure you write that down. Or reactivity. Two separate words for the same exact thing. That when people know they are being observed, they act differently. Ethically, you usually must tell people you're observing them. And so you have to then combat that by observing for a long period of time. And then how do you know if their behavior is actually natural? And observations can be distorted if the observers approach the situation to see certain behaviors, right? They have that bias where they're looking for that behavior. And if they see it, they kind of blow it up in their minds. Case study is the next one. So this is an intensive examination of behavior or mental processes of an individual or a small group, right? A certain person, type of person, or situation. Patient HM is an example of this. He was called Patient HM to protect his identity, but he had brain surgery that removed part of his temporal lobe and I think even his hippocampus. And so they kind of just observed him to see what would happen, because you can't just find Joe Schmo off the street and say, hey, let's go do brain surgery and move your temporal lobe and your hippocampus. That's incredibly unethical. But when it happens out of medical necessity, you then want to observe and do a case study on that particular person to see what the effects are. So they're really useful when something is really new, complex, or really rare, like when someone has a lobe of their brain removed, right? Like that's really rare. And it's often used in clinical work and in neuropsychology. But there's really limitations there. It may contain evidence that a certain research thought to be a problem, right? And it really was a problem with this one person, but it doesn't mean it's a problem with the entire population. And they're also unlikely to be representative of the people in general. So you have to be very careful, and this is the biggest problem with case studies, so make sure you write this down, that with a case study, you cannot generalize. It's called generalizing to the population. You can't say that what happened with this one or few or 10 people happens with everyone. But it still provides valuable material for further research, right? It gets the ball rolling, serves as a testing ground for new treatment, training programs, and other applications that are really important for research. Survey is the next method that we're going to talk about. It's a technique for ascertaining those self-reported attitudes, opinions, or behaviors of people. That's usually done through questioning, right? Questioning that representative and random sample of people. You know what a survey is. You answer questions. It can be used as part of the operational definition within experiments. So if I'm doing an experiment on how the color of socks impacts happiness, and I'm measuring happiness, well, guess what? Happiness is an attitude, right? It's a feeling. And really the only way to assess it is through self-reporting. And so my operational definition within my experiment of my dependent variable is using a survey. Okay, validity of data depends upon a few things here with surveys. It's all about how the questions are worded and making sure that they are not leading people to answer it a certain way, because then the whole thing is just botched. But also then representativeness of people surveyed. You can't just interview or survey a few particular people and then say that applies to everyone, because it doesn't apply to everyone. You didn't include all types of people. Other limitations would be willingness of people to honestly participate in the survey and complete it, not just do a few. And people may say what they believe they should say, right? They say what they should say on the answer, not what is actually true. It's still a great way to gather large amounts of information in a really effective and really efficient way. It's not expensive and you get lots of data. All right, the last one we're going to talk about is what's called a quasi experiment. So in our next set of notes, we're going to talk about what an experiment is. But in this one, let's talk about quasi experiment. These are studies that have the same control as experiments, yet do not include random assignment of participants. That may not make a ton of sense for you right now, but it will when you take the experiment notes. So let me kind of bring it back and simplify it for you. Quasi meaning almost fake. It's like a fake research. And the reason why they have to do fake research is because it would be unethical to do it for real. So an example, researchers want to test the hypothesis that a pregnant woman's use of psychoactive drugs will cause abnormalities in her developing fetus, in the baby. Now, let me ask you this. Would it be ethical to first gather some participants and say, I'm assigning each of you to get pregnant, and I'm assigning each of you to get pregnant? First of all, you can't do that. You can't assign pregnancy to someone. And then to say to your experimental group, okay, now you guys are going to inject crack cocaine 3 times a day. No. You can't do that to regular human beings, let alone those who are pregnant, right? It's unethical. Here's the thing. Does it exist in our, frankly, jacked up world that there are pregnant women who consume psychoactive drugs? Yes, unfortunately, there are. And so if you find those women and you observe and you do an experiment recording what happens, that's a quasi-experiment. Conclusions in a quasi-experiment are not as firm as those in true experiments, but they allow research to be conducted on topics and in settings that would otherwise be impossible to do. And that's because most of the time of ethical reasons. So that wraps up our kind of overview of research methods. In the next set of notes, we're going to talk about experiments and get really nitty gritty about that. So go ahead and click in the station to see that next video, and I will see you there.